Also, before we get started, we should do a brief overview of SQL, or Structured Query Language. SQL is another topic entirely if we wanted to discuss it in depth. Rather than losing focus, we will keep our attention on Java and JDBC and summarize only a few SQL keywords that we can use in generating Java JDBC statements for queries against our database. Here are some SQL keywords. Select, which selects and retrieves fields from one or more tables. From, which specifies tables from which to get fields. Where, which sets criteria for rows to be retrieved. Group by, which sets criteria for grouping. Ascending and descending, which order things in ascending and descending order. And the logical operators and or. And meaning both sides have to be true, and or only one side has to be true. There's order by, which sets criteria for ordering and sorting records. Insert into, which inserts values into one or more tables. Update, which updates existing data in specified tables. And delete from, which deletes data from a specified table. As part of our review of SQL, let's go through a couple of examples. In these examples, the SQL keywords are in green, and database tables and field names are in white. In example 1, we're simply going to select and use order by. So we would say select the field names ID, first name, last name, SSN, and pay rate from the table employees, and we're going to order things by first last name, then first name, and then SSN. In example 2, we're going to use where and like to specify additional criteria. So again, we're going to select the fields ID, first name, last name, SSN, and pay rate from the table employees, where the last name is Germany, like Germany, and we're going to order it by SSN in descending order. In this third example, we're using the logical AND. We're going to select the fields ID, first name, last name, SSN, and pay rate from the table employees, where first name is like Charles and last name is like Germany. Remember, with logical AND, both sides have to be true. So first name has to be Charles and last name has to be Germany to create a match. Finally, we're going to order by SSN in descending order. If you look at the fourth example, we're using the logical OR. And remember, with OR, only one side has to be true. So we're going to select the fields ID, first name, last name, and rupees from the table Hyrule, where first name is like Link or first name is like Zelda, either one. And then we're going to order by rupees in descending order. Here in example 5, we're going to look at selecting fields from more than one table. To do this, we need to use commas and the dot operator. So notice how we're doing this. We're selecting the fields first name, last name, and kills ratio from two different tables, players and CPUs, where from the first table, players, the last name field is the same as the second table's last name field. Using the dot operator, we say the table name and then the field name. And then we're going to order by kills ratio, and this time we're going to put it in ascending order. In example 6, we're inserting values into fields that already exist. So we're going to insert into the table players the fields first name and last name, and the values Charles and Germany. Here are a few more examples. In example 7, we're updating information in fields. So we're going to update the table employees, and we're going to set the field SSN to have the value 24698763955, whatever value it may have had previously, where last name is Germany and first name is Charles. In this case, both have to be true because we're using logical AND. In example 8, we're creating a table. We simply use create table. We're going to give the table the name ponies, and we're going to put two fields in that table, the ID field and the pony name field. The ID field will act as the primary key, so I specify integer in purple there. And pony name will simply be string data, so I specify text 32, also in purple. Finally, in example 9, we're deleting a table, and to do that, we'd simply say drop table, and then the table name, which is ponies. In our last two examples, let's review inserting information. In example 10, we're going to insert into the table ponies the values 1 for the primary key. Remember, that was in integer format. And then the value starlight, which was in string format for pony name. In example 11, we're simply selecting all the records from a table with select, the asterisk, which is the wildcard from, and then the table name, which is ponies. So much to review, and yet we still haven't written a single line of code yet. Hang in there, we're almost done, and we'll be ready to begin soon. Let's briefly review some terminology and concepts necessary to use JDBC to connect to and manipulate databases. First, there's the concept of reflection. Reflection is commonly used by programs which require the ability to examine or modify the runtime behavior of applications dynamically after being compiled. Java.lang provides classes that are fundamental to the design of the Java programming language. And Java.lang.reflect provides classes and interfaces for obtaining reflective information about classes and objects. So often you will import objects from this package in JDBC projects. Continuing with the idea of reflection, there is the forName method. The forName method returns the class, object, or interface associated with the string name that is passed in as an argument. This provides for the dynamic loading of Java classes. In other words, we can dynamically code a program to load undetermined code at runtime. The program determines at runtime without knowing previously the specific object it needs to build. This allows Java to build dynamic and flexible systems that can progress and change without requiring a recompilation for each change. The method class is an object often used with reflective code. The method class can be used to get any or all of the methods contained within a class. It comes from java.lang.reflect.method. It is useful when implementing reflective code where you are dealing with classes dynamically at runtime and are not quite sure just what classes or methods you might be retrieving. Take a look at the following example. Here we're dynamically loading a class that's unknown until runtime with the forName method. Notice we're importing java.lang.reflect method and java.xSwing. Now in our main method we have to declare it to throw an exception, or we'd have to put where we're using the forName method inside of try and catch blocks. To save space, I'm just having the function throw an exception. Either way, we're firing off a JOption pane and we're going to use an input dialog to get from the user what class they want to load. Now here's the thing, this is completely undetermined until runtime. They could type in banana, they could type in supercalifragilistic. We have no idea what they're going to type in. It's an unknown variable. Because of that, we have to use the forName method to load the class or build the object. And that's what we're doing next. Now you'll see this used all the time in JDBC ODBC bridge projects. They'll use the forName method to load the JDBC ODBC driver. Next, we're going to instantiate a method class object called the chosen one's main method. And we're going to go call the function getMain, passing in the chosen one. Well, the chosen one is whatever class they typed in. We have no idea what methods are in the class until runtime, or what they're going to type in until runtime. But whatever that class may be, we're going to go and look through all of its methods. And if you look in the getMain function in this example, that's what we're doing. We have a for loop. And we're going to go through all that class's methods until we find something that equals main, that class's main method. When we do, we'll return that index and subscript value on member methods in this case. And then once we do this, the chosen one's main method, we can then invoke or run that method, that object's main method here. Alright, so let's review the process again. We're going to use forName in this example and also in the future in all of our JDBC projects to dynamically load a class typed at runtime, or to dynamically load an object that's not determined until runtime. Alright, now here we're invoking a function that we don't really know what it is until after we load the class at runtime. Again, this is an undetermined variable. It's an uncertain thing. So this is why we have to do it this way. We have to use forName, we have to use a method, we have to use invoke. And here we're just getting that method. We want to look for and find the main method, and we're going to run it. So let's see how this looks in NetBeans, and we'll run the code. Look, here's the same code you saw in the previous slide, where we want to dynamically load a class with the forName method. And the class we're going to load here is going to be treasure.java, and it's only going to do one very simple thing. It's simply going to fire off a JOption pane, and it'll say you found the master sword. Go Link! Alright, so we have to make sure we type in the right class that will match that class. I couldn't type in banana or supercalifragilistic. I've got to type in treasure. But still, just to illustrate the concept of the forName method and how it works, we're going to run this, and I'll show you that even though this program or this class doesn't know what class it's going to load until I run it, it can handle it after I type it in using the forName method. So let's go ahead and run it. And it's going to ask me, well, what class should I load? And I'm going to type in treasure, the treasure class. When I do, it loads the treasure class and it says, you found the master sword, yay! Now again, if I were to type in something that it couldn't find, supercalifragilistic or something, then notice what happens down here. It's unable. So you can see, I still have to match a real, actual, valid class, or I'd have to somehow handle the exception. But I truly can create reflective code, and I can use forName to load something that is not really determined until after I launch the program. Now let's take a look at some of the steps needed to connect to an ODBC database. Step 1. Load the JDBC ODBC driver. Take a look at the following code. Here we're dynamically loading the JDBC ODBC bridge driver at runtime with the forName method. This is how most JDBC ODBC and SQL projects load the JDBC driver. In this case, in our class, we call the forName method to dynamically load the JDBC ODBC driver at runtime. Here's the same code in NetBeans. We're going to run it, and it's simply going to test and see whether or not we can connect to the JDBC ODBC driver. And so if we run it, it's not going to do much other than give us a build successful and everything's okay. Otherwise, we would get an error message. Step 2, connect to the database. Remember that there are DSN and DSN-less connections. A DSN connection uses a data source name that you must create prior to coding the connection code. A DSN-less connection implements a direct connection that interfaces directly with the database without the need for defining a DSN. In example 1, we're going to implement a DSN-less connection or a direct connection. In this example, we're going to create a direct or DSN-less connection to a database in JDBC. Now, in our class, the first thing we have to do is instantiate a connection object. So we're going to do that, and we're going to initialize it to be null. We need this connection object, in this case from the java.sql package, to be able to build and set a connection to our database. Then, we need the physical path to the database. In this case, I'm using the absolute path, the drive letter, the directory structure, or the path, and the file name, inventory.mdb. Next, we have to specify the database driver. In this case, JDBC ODBC, and it's going to be the Microsoft Access driver. And then I'm concatenating that to the previous string, which was the path and name of the database file. Then we need to load the JDBC ODBC bridge driver with the forName method dynamically, like so. Finally, we need to call the getConnection method on a driver manager object and assign the return result to our connection object that we previously instantiated. We're going to do all this, and as we do it, we're going to pass in this case, our concatenated string database as the argument or the parameter. Here's the same code in NetBeans. And again, we're setting up a direct or DSN-less connection to a database in JDBC. This means we don't have to create a DSN or data source name first. In this case, we're going to connect directly to the database files. So, our first string has the path, directory structure, and then the name of the database. Our second string is going to specify the driver, in this case access, and we're going to concatenate to it the very first string. So they're concatenated together, and then that string will later pass in to specify our connection. So database is passed in as an argument, and we call the getConnection method on a driver manager object, and we assign the return result to our connection object that we instantiated up here at the beginning. So let's run it. And you can see that we were able to connect successfully to our database directly without a DSN. Otherwise, we would have gotten a stack trace. Now here's just another example. You can play with the string and do different things with it and figure out how you want to concatenate it or massage the data backwards and forwards. But this is just another way of doing the same thing, right? So I'm going to run this one as well. And you can see that that also would connect to the database. Although here we're specifying an additional driver option and read only. In example 2, we're going to implement a DSN connection. In this example, we're going to create a DSN-based connection. So this is not a direct connection. In this example, yes, we would have to go and set up a DSN our data source name first before we could then connect to it using this code. And it's a little bit different, but here are the steps. First, we're going to specify the name of the DSN that we previously set up before we began to code this project. And then we're going to concatenate it and combine the JDBC ODBC driver and the DSN name. Okay, we're going to dynamically load the JDBC ODBC bridge driver with the forName method. And then we're going to call the function getConnection, passing in our string as an argument or a parameter to the driver manager object. And we're going to assign the return result to a connection object called connection. And here's the same code in NetBeans, so we can see how it works. Here is our DSN name, and here is our driver being concatenated to our DSN name. We're dynamically loading the JDBC ODBC driver with the forName method. We're taking a driver manager object and calling its getConnection method, passing in our newly concatenated string as the argument or the parameter, and we're assigning the return result to a connection object called connection. And again, this won't really do anything other than give us an error if there's a problem. So let's run it and see if we can connect to our DSN. In this case, yes, everything's successful. And usually when I'm starting out a project, I'll do this first. I'll kind of test connectivity because there's a lot that can go wrong when you're setting up DSNs, the path, the name of the DSN, or even if you're doing a direct connection and you're not using a DSN. It's kind of a good idea to test things as you go. Step 3. Creating and executing statements. Once we successfully create a connection to our database, either via a DSN or a direct DSN-less connection, we'll want to create statements and generate SQL strings and then do things with our database like query it or add things to it, remove things from it, and so forth. So let's look at the basic steps for creating and using a statement. First, we want to declare a statement. And we can do it locally in a function or, like I'm doing it here, globally. Next, we'll want to call the method create statement and then on a connection object, assign that return result to our statement object. And that's what we're doing right here. Next, we'll then want to create a SQL string. In this example, we're using the wildcard and we're saying select everything from a table called inventory. Fourth, we want to execute the statement with the SQL string and store the results. This is sort of like a command object if you're used to programming things with the .NET framework or MFC projects. And we're going to call the method or the function execute query on our statement object, passing in the SQL string as an argument or a parameter. And we're going to assign the return value to our result set object. If you look over there at the top of the class in globals, we're declaring a result set object called result. So that's going to store or hold the result of running that SQL string or query, select everything from the table inventory. Once we do this, we're then going to generate a while true loop, and in that while true loop, we're going to take our result set, result, and we're going to call the next method. And it's simply going to go down all of our records row by row by row by row by row from the database table and read all the records one by one. And finally, 6, we want to get the field values for each record in this example, and we're just going to display them in the console with system out print line. We could also generate a GUI for this, but that'll be for another time. Here's the previous code, but this time in NetBeans. Here's our 3 globals, a connection object, a statement object, and a result set object. Now, there are several ways we could code this. We could simply make all our methods and our global data members public and static. But if you don't want to do that, we could simply make main public and static, and then we could instantiate or build our class from within main using the constructor, and then everything else can simply be public and void. Either way, I'll do it multiple ways or different ways. So I try to, or I like to show you, 3 or 4 ways of doing the same thing, and you can find the one that works the best way for you. But in this example, we have 2 methods of connecting, connect 1 and connect 2. Connect 1 is going to build a direct or DSN-less connection, just like we covered previously. And method 2, connect 2, is going to build a DSN-based connection. So the first one we'll try is connection 1. Then later we'll comment it out, and I'll uncomment connection 2. And you can see that using either method, as long as I set up my DSN right for connection 2, they both work and they both generate the same results. So either way, once we set up our connection, we're then going to go call the method display data. Well, what does display data do? We take our global statement object, and now we're going to create it with create statement on our connection object, and we're going to assign the result to our statement object. We're going to generate a SQL string, in this case to select everything from the table called inventory. And then once we do this, we're going to store the result in our result set result once we call the method execute query and pass on our string, our command, as SQL. Okay, here's our while true loop. And again, we're just going to go through the database table row by row by row by row by using the next method on our result set. And when we do this, we're going to call getString, and so we're going to return as string data the values stored in each of these fields: ID, name, quantity, and price. And finally, we're going to display them all in the console. Okay, so if I were to run this right now using the first method, connection1, it'll connect to our database directly without a DSN, and this is what would happen. And you can see here's all the data stored in my Access database file. Okay. And now let's see what happens if we use a DSN. Alright, we'll rebuild the project. So whereas before we did a direct connection without a DSN, now we're going to use this method and connect using a DSN. And again, the results are the same. And if you want to see the Access database, let me go, let's see, Java inventory, let me hop over here. And there's, oh, by the way, there's a lock file here because I've got it open. It generates a lock file to keep it from being accessed by, more than one application at a time. But we're to view the contents of the table. Just load it up here. You can see there's ID, name, quantity, and price, and here are the values stored in the table. And this is exactly what our JDBC ODBC driver returned to us using our result set. Step 4. Using SQL with statements to create, delete, and modify tables. In this next example, there's more code than I could fit in a single slide, so we're just going to look at it in NetBeans. And before we get started, notice some of the preliminary things that we've had to do in any JDBC project. In this case, I need to import java.sql because that has so many of the objects I need. In this case, a connection object, and then statements and other things. Also, we have two globals here, and these could just as easily have been declared locally within a function, and sometimes that's a better option than making them global. But for now, I'm going to use a global connection object called connects, and I have a global string called table, which is just going to be the table name. And that would make it easy for me to change it so that if I did it here, then in all the other functions, it would reflect the change in that table. Until we actually get to the point where we create a graphical interface for this, and we make it easier to update things. So that's just to kind of make things easy to modify. I'm going to scroll down here to the main method, and I tried to break things up into distinct modules of code or functions that would illustrate the different steps of connecting to a JDBC ODBC database, creating statements, setting up SQL strings, and then executing commands and queries against a database. So the very first function that we want to look at is connect, and that represents the first thing that we need to do before we can do anything else. Create a statement, build up a SQL string, execute commands, do anything with the database. We have to find and connect to the database, which means that we either need a DSN, a data source name, or we need a direct path to a database file somewhere, and we need to select the appropriate driver for whatever database technology we're using. So I'm going to scroll up here to the connect method, and in this example, I'm not using a DSN. Okay, so this is a DSN-less, or a direct connection to a database without using a DSN. Now, I still have to dynamically or reflectively load the JDBC ODBC driver bridge here. And I'm doing that using the forName method. Remember, we talked about that previously. And I have two strings here. In this case, database file, which is the directory and path and name of the database file. And then database here, which is the driver, in this case for access, concatenated to the directory path and file name of the database. So all that together becomes this database string once it's concatenated, and I pass it in as an argument or a parameter to the getConnection method, which is called on the driver manager object. And finally, the return value of that is going to be assigned to our connection object. Remember, our global connection object connects. So we only have to do that once, and once we do that, we're connected. We found the database, we've connected to it, we've selected the appropriate driver and path, and we're ready to start doing other things. So let's take a look at the next method, and I'm going to scroll down. After we connect, the next thing we're going to do is create a table. All right, we're going to make a brand new table in our database. And I'm just going to show you what this looks like. Here's my inventory.mdb file. And I have both a DSN to this in a different location, and then I have this set up locally here at d:\Java. Well, in this example, I'm not using the DSN. This example, I'm connecting directly, and if you look at it, it only has one table in it, inventory, with 4 fields. Here's the primary key, ID, name, quantity, and price. Okay? There is no ponies table, you will notice. Well, we're going to go ahead and create a table so we can see how we do that using a combination of SQL and Java code with JDBC. So let's go take a look at that function. And in create a table, we're going to create a statement. When we do this, we have to put it inside of try and catch blocks. Many of the JDBC processes that use SQL and different database activities, they need to be put inside of try and catch blocks, and you catch different kinds of exceptions. I'm taking the lazy way out and just catching anything. Exception is just a default exception. It's not very descriptive, but it catches everything. So that needs to be in try and catch. And then the first thing I need to do is create a statement, right? So I go ahead and instantiate a statement. I'm going to call it state. And the way that I do that is I take my connection object, right? That's my global connection object, connects, and I call the method create statement on it. And that creates my statement. The next thing I have to do is create a string that's going to have the SQL command in it that I want to pass along to my database to actually create the table and whatever fields I'm going to add to it. And that's what I'm doing here. The SQL keywords are create and table, and then I'm concatenating into the string the table name, which remember up here that was ponies, if you're a bronies. And then I'm adding the rest of the string here, and in this case, inside of parentheses, notice that NetBeans highlights that in yellow there in the string. I'm creating one field for the primary key called ID, and the data type is going to be integer. I separate that with a comma, and then I'm creating a second field called pony name, and it's just going to be string data, so it's text 32. Alright, so I'm just going to generate 2 fields. This will be the field name, and this will be the data type of the field. You can see by what I'm highlighting. So I create that SQL string, and when I'm done, I then take my statement object, I call the execute method, and I pass in my SQL string that I created up here. Okay, and then when I'm done, I can close my statement. And that would have the effect of actually creating the table in the database. Okay? Scroll down, look at the next thing we're going to do. Okay, once we do that, once we create the fields, how would we take a table using SQL and insert values into fields that have been created or that previously existed? Well, let's go take a look at that method or that function. Insert values into table. Again, it needs to be in try and catch blocks. Again, I have to build a statement the same way we did before with our connection object and create statement, assigning it to a new statement object. Again, I need some kind of a SQL command, and I wanted to give each of my ponies a different name instead of giving them all the same name, so I just made an array of 5 strings here. Alright, Starlight, Lemon, Sprinkles, Buttercup, Moonbeam, and Shadow. I'm going to create a for loop as just a quick way of populating or setting up those values, and then I'm going to build up my SQL string. And the SQL command is insert into the table. I'm concatenating into the string, which is going to be ponies. And then values, this lets me specify field values using SQL. And then again, inside the parentheses is where I'm going to put the different variables. Well, I'm going to use count, which is in my for loop, right? And I'm adding 1 to it. So I don't want to start at 0, even though the loop starts at 0. I want to start at 1. And there's a million different ways to code that. So it'll count 0, 1, 2, 3, 4. But in the database, for the key value, the primary key, it's going to do 1, 2, 3, 4, 5. Either way, but I'm just concatenating that in, right? Separating it with a comma. And then as a string value, I have a single quote. Okay? No, not an escape sequence, that's just a single quote as part of the SQL string there. And then I'm just going to take my array here, right? My array of strings, pony names, and that's based on the value of count. Well, remember, count starts out at 0, it has a postfix increment while it's less than 5, so it's just going to go 0, 1, 2, 3, 4, and then break out of the for loop. So the pony names would be set to Starlight, Lemon Sprinkles, Buttercup, Moonbeam, and Shadow. And then we break out of the for loop. And finally, I'm going to go ahead and close my statement, and I'm done. Let's scroll down to the next function, display table. Okay, what does display table do? Well, let's take a look at that. Again, it must be inside of try and catch blocks. Again, I have to create a statement using my connection object and assign it to a new statement. Again, I need a SQL string, and this one's really simple. In this case, I'm going to use a wildcard, the asterisk, and I want to select everything from my table name, which is ponies. I'm going to call the execute method on my statement, passing in the SQL string. When I do this, I want to get the result set. The result set is, whatever is returned as the result of me passing in that SQL command. So I'm going to do that, and I'm going to store it inside of an instance of the result set class object called result. So I'm instantiating or building a result set object, calling it result, and what I'm doing is I'm calling get result set on my statement object and assigning that return value to result. Okay? Then we're never quite sure exactly how many records we're going to have. This is sort of a dynamic thing. So what I'm going to do is sort of code a dynamic or a flexible while true loop. In this while true loop, we're going to say, well, as long as result is not equal to null, in other words, we haven't reached the last record in the database, so the pointer is not pointing to null, not pointing to nothing. And remember, the logical and means both sides have to be true, so it can't be pointing to null, and I can move on to the next record. In other words, using the next method. Well, that has the effect of causing it to go down the records row by row by row in the table. So inside the while true loop, it's going to do that. What am I going to do? I'm just going to print the results. So I'm going to take my result set, result right, and I'm going to call getString. The argument here is the field. Remember, the first field we created was an integer format, and it was ID. It accessed the primary key in the ponies table for our database. Okay. I'm going to call getString again, and this time I'm going to get the second field. Remember, that was a string value. Okay, that was in this case, where we store the pony's name. So I'm just going to display that in the console, and then I'm going to close my statement. Okay? And then the last thing I'm going to do is delete the table. And again, notice that I have to put things inside of try and catch blocks. Let me move my try over there a little bit. Things go inside of try and catch blocks. I'm creating a statement and assigning it to a statement object again. Here's my SQL command, which is simply drop table and the table name, which is ponies. And I call execute on my statement object, passing in the SQL string, and I close the statement. Okay? So you can see step by step what each of those functions does and how you would code the SQL string. Now I'm going to comment this one out because I don't want to delete the table just yet. I want you to be able to see the results of it. And then later we'll use that function to go clean things up and remove or undo the thing that we just did. So let's rebuild the project and run it and see what happens. And again, remember, if you look at this database, there's only one table in their inventory. There is no ponies table there yet. Okay? So let's rebuild it. And let's go ahead and run our project. Okay, and when we do, notice it displays in the console here from display table all of our ponies. The primary key values 1, 2, 3, 4, 5, the name, Starlight, Lemon Sprinkles, Buttercup, Moonbeam, and Shadow. And again, I'm going to go here and I'm going to open this. Notice there's our table now. It added our table to our Access database. And if I open it, you'll be able to see here's the field values, ID, and pony name, and the primary key value of 1, 2, 3, 4, 5, and Starlight, Lemon Sprinkles, Buttercup, Moonbeam, and Shadow, respectively. Okay? Notice the little lock file there. You don't want to try to access an Access database from more than one application at a time simultaneously, and that lock file sort of prevents that. Okay, so let's say that I wanted to delete the table. Okay? In this case, I still need to connect, but I don't want to create it because it's already been made. Don't want to insert any values. Don't want to display it. I'm just going to delete it. Remember what the code to delete the table did. So again, I'm going to rebuild the project. I'm going to run the project. It was successful. And now let's open the database and see what happened. And notice the ponies table is gone. So this project, is concise, short, simple, hopefully to the point, but it will give you an idea of how to do the basic things that you need to do to connect to a database, JDBC, ODBC style, and then after you do that, how to create statements, execute them, and generate SQL strings and run commands, queries, and things against the database to do different things with the data.